Okay, let's take a look at the notes for section 7.3, proving triangles are similar. Let's first answer the questions. Name the postulate or theorem you can use to prove triangles are congruent. Recall this from a previous section. Number 1, we could say is congruent by side, 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 congruence postulate. Number 2, by side, angle, side, congruence postulate. And number 3, by angle, side, angle, congruence postulate. Also recall that there are 2 other postulates, angle, angle, side congruence postulate, and the hypotenuse leg congruence postulate, when we want to prove that 2 triangles are actually congruent, which means they're identical. But now we're going to look at similar triangles, which means that the angles will be congruent and the sides will be proportional. So how can we prove that 2 triangles are congruent, or are similar, not congruent, but are similar? One postulate we can use is the angle-angle similarity postulate. So this says if 2 angles of one triangle are congruent to 2 angles of another triangle, then those triangles are similar. So here I have that angle T is congruent to angle P, and I have angle R is congruent to angle L. Because of the triangle angle sum theorem, therefore, I get that angle S is congruent to angle M. So all I really need are 2 angles, and I can say I have similar triangles. Remember a congruence statement. This is the similarity statement. So the only difference between a congruence statement is the similarity symbol versus the congruence symbol. So in example 1, it says, using the angle-angle postulate. So explain why the triangles are similar, and then write a similarity statement. Well, by angle-angle, I know I have angle R and angle V congruent. And then I have vertical angles in the center, so therefore I have angle WSR congruent to angle BSV. So therefore, by angle-angle similarity postulate, I have 2 similar triangles. The similarity statement would then be triangle WSR is similar to triangle BSV. Remember, those corresponding angles should be in the same position. So those corresponding angles should occupy the same position. Critical thinking, in example 1, you have enough information to write a similarity statement. That's the similarity statement right there. And it asks if you have enough information to write a similarity ratio, and the answer is no. You need side lengths. You would need side lengths in order to get that similarity ratio. Moving on to the next postulate or theorem, by side, angle, side. So this theorem says if an angle of one triangle is congruent to an angle of a second triangle, and 2 sides, and the sides including the 2 angles are proportional, then the triangles are similar. So let's take a look. If I have these 2 triangles, let's call this A, B, C, and we'll call this one D, E, F. Let's say I have angle B congruent to angle E. So when I look at this, I have angle B congruent to angle E. So if I have AB is to DE as BC is to EF. So if those ratios are equal, then I have those two triangles similar by side, angle, side similarity. The next one I can use is side, side, side similarity theorem. If the corresponding sides of two triangles are proportional, then the triangles are similar. So when I look at this, again, let's say I have these two triangles, say CAT and DOG. Let's say that triangle CAT is similar to triangle DOG. By side, 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 that means that the ratio of CA to DO is the same as the ratio of AT to OG, as CT is to DG. So by side, side, side similarity theorem, we can say those two triangles are similar. They have congruent angle measures and their sides are proportional. So in this example, using similarity theorems, explain why the triangles must be similar and write the similarity statement. Okay, so we have QR is to XY as PR is to ZY. So 3 is to 4 as 6 is to 8. So therefore, I have sides proportional and I have a congruent angle. So I have triangle QPR similar to triangle XZY would be my similarity statement. The next one, I have AC congruent to EG. I have AB congruent to EF. And I have then BC congruent to FG. My ratio is 6 to 8. 9 to 12, and 6 to 8. When I reduce that, I get 3 to 4, 3 to 4, and 3 to 4. So by side, side, side similarity theorem, I can say that I have two similar triangles. Triangle ABC is similar to triangle EFG. Next, we're going to use this similarity ratios to find the length of a missing side. It says if the triangles are similar, find the length of DE. Well, here's DE. I'm going to call that X. So the first thing I have to decide is, are these two triangles, this one and this one, similar? Well, I know that I have vertical angles here. So I have angle ABC congruent to angle EBD. So the next thing I have to know is if I have those sides proportional. So AB is to BE as CB is to DB. AB is 12, BE is 18, CB is 16, BD is 24. Both 12 and 18 are divisible by 6, and I get 2/3. 16 and 24 are both divisible by 8, and again I get 2/3. So I can say that these triangles are similar, and my similarity ratio is 2 to 3. So I can use my similarity ratio, 2 is to 3, to compare the side that I have. 10 is to the side that I don't have, X. So 2x equals 30, so x equals 15. And that's the length of DE equals 15. Next is indirect measure. And we use indirect measure when we need to find the length of something, but we can't measure it directly. So we use indirect measure to calculate a value we cannot measure. Okay, let's look at this example. So we have a geyser here, JS. And let's say we can't measure that geyser. We want to know the height of that. We have a person over here, and we know that that person is 6 feet tall. So we place a mirror so that the angles here are the same. And then we have right angles here. So by angle, angle, we know we have similar triangles. Now we have the length that the person is from the mirror and the length that the geyser is from the mirror, or the base of the geyser. So I can set up a proportion that talks about the height of the person over the height of the geyser. And that's equal to then the distance from the mirror, the distance the person is from the mirror, and the distance the geyser is from the mirror. So the height of the person is 6 feet, the geyser is x feet. The distance the person is from the mirror is 7 feet. The distance the geyser is 4.5 feet. When you cross multiply those, you should get 243 equals 7x. So x is equal to 34.7 feet. So the geyser is approximately 34.7 feet. Let's look at another example. It says, in sunlight, a cactus casts a shadow that is 9 feet. So there's the cactus's shadow. At the same time, a person 6 feet tall casts a 4-foot shadow. So we know she is 6 feet, and we want to know the height of the cactus. So if we put the height of the person is to the height of the cactus as the length of the person's shadow is to the length of the cactus shadow. Notice we're keeping those like quantities in the same locations. So the person's height is 6, the cactus height is x, the length of the person's shadow is 4, the length of the cactus shadow is 9. Cross multiply, you get 54 equals 4x, so x is equal to 13.5. You could also have set this up as the person's height to the length of the person's shadow. So you could have also said 6 is to 4 as the height of the cactus, x is to the cactus shadow 9. Again, you would have gotten 54 equals 4x, so x is equal to 13.5. It's important to write those words down so that you can see the relationship between the height of the cactus and the height of the person. Next example, it says explain why the triangles are similar, then find the distance represented by x. X is the actual height of the giraffe. Here I have a right angle. Here I have a right angle. Here I have two congruent angles. So by angle, angle, similarity postulate, I have two similar triangles. So I have the person's height, 5 feet, 3 inches, and I want to convert those 3 inches to be in terms of feet, or convert the feet totally to inches. So I'm going to convert this 5 feet 3 inches to 5.25 feet, because 3 inches is 1/4 of a foot. 1/4 is 0.25. So now I'm going to take the person's height and the height of the giraffe is equal to the distance the person is from the mirror. I'm leaving a few words out, I hope that's okay, over the distance, I'm abbreviating as well, the giraffe is from the mirror. So the person's height, 5.25, is to the giraffe's height, x, as the person's distance, 5 feet, is to the giraffe's distance, which is 15 feet. You could reduce that to 1/3 if you wanted, but when you cross multiply, you would get x is equal to about 15 feet, 9 inches. Okay, and convert that decimal back to inches. Finally, number 2, we're looking at the distance across a river. So this is the distance we're looking for. We are given a distance along the bank and a right angle. We're given another distance that appears to be parallel and a right angle, and then the distance from that parallel line to the bank. So we have two similar triangles, so we could say the side perpendicular to the river is to x, so 15 is to x, as 120 is to, or is 20 is to 120. Sorry, as 20 is to 120. Cross multiply, you get 20x equals 1800. So x is equal to 90. So the distance across this stream is 90 feet. The homework's attached. It's due tomorrow. We'll go over it in class, and then we'll start on section 7.4. Thank you, and I'll see you tomorrow.